Hello there everyone, and in this video I will be explaining to you how you can create a C++ program for Gaussian elimination or Gauss elimination. Now I will presume that you have some requisite information or knowledge about what Gaussian elimination is. Nevertheless, let me just give you a brief introduction of the Gaussian elimination. Now according to this presentation that I found over the internet, Gaussian elimination consists of two steps, that is forward elimination and back substitution, where let's say you have some equations of the kind 25x1 plus 5x2 plus 1x3 is equal to 106.8, and 64x1 plus 8x2 is equal to 1x3 is equal to I'm sorry, that was plus I guess I've been saying is equal to. Anyway, so 64x1 plus 8x2 plus 1x3 is equal to 177.2, and 144x1 plus 12x2 plus 1x3 is equal to 279.2. Now what you do here is that you convert these equations into these kinds of matrices that you are seeing here. Separate the variables and put them in a column in a matrix that you may call capital X, and another matrix which would contain the coefficients of these variables, and the matrix on the other side would be the matrix of the RHS, a column matrix of the RHS. So this is your matrix, and now what you need to do is you need to perform the steps such as you make, and these diagonal elements, they may be called the pivot elements. I'm not too sure if technically that's the correct term to be calling them, but I'll be calling them the pivot elements. Okay, so now what you need to do for Gaussian elimination is that you need to make the elements below the pivot elements 0. Like here 25 is the pivot element, so you need to make these 0, and then to make the element below 8 0, and then below and then 1 is the pivot element, so you cannot do much about it. Anyway, so you can perform three kinds of row processes or row transformations or something like that, whatever it's called. Row operations, I believe, is the correct term for that, and then I will not go into further detail about what those are. Anyways, after that you will have a matrix that looks like this, and as you can see that 0.7x3 now is equal to 0.735. So now you have the exact value for x3 as 0.735 divided by 0.7, and then you can substitute it in this previous equation, where after you substitute the value of x3 0.7 whatever you get, and then you will find the value of x2, and similarly when you substitute the values of x2 and x3, then you get that was a backward elimination, I'm sorry, what's happening. Okay, so that's called the backward substitution, so that you can get finally the the values of these coefficients. Anyways, so now let's jump into how to program this code for C++. Okay, so here's my document. Yeah, I'm using virtual. If in case you're wondering how am I running this Linux on, or Ubuntu to be precise, I'm using this software called VirtualBox provided by Oracle. It's pretty good. Anyways, so here's your program of Gaussian elimination for C++. Bear that in mind. Okay, so now what do we need to do? Let's go over the checklist. Okay, so first of all, let me show you one more example. Now as I told you that the elements below the pivot elements need to be made 0, one important condition to this is that sometimes while you are performing your row operations, as you can see in this example right here, you can see that the first pivot element is 0, and that's not gonna do very good for us in providing the answer for our equation. So what we do is we swap the row 1 and 2. Okay, like you had these equations and you formed an augmented matrix here. Bear that in mind that it is called an augmented matrix. What an augmented matrix is that it has the coefficients of all the variables and plus one more column for the RHS of the equation. So overall the augmented matrix has n plus 1 more columns for n equations but only n rows. Okay, so you need to swap it, and this process is called pivotization or pivoting, whatever. So here's a program. You ask the user to enter the number of equations. He will enter n, then you will have to declare a matrix of n and n plus n rows and n plus 1 columns. Why? Because I already told you that your program is the augmented matrix contains the RHS column too, so it will need to have one more column. Now then you ask the user to enter the elements of the augmented matrix row wise, and here's the code for that. I assume that you will understand it. It's pretty basic, because if you don't understand this then you will need to go over some basics for array inputs and outputs. And anyways, so over to pivotization. Now how to perform pivotization. Now pivotization is pretty easy, and keep in mind that what we are going to study is partial pivotization, not a complete setup, because a complete or total pivotization would be making the pivot elements the largest in the matrix. For example, if you see this matrix right here, now this was 0, so what we will do is we go over this column and find out if there exists any greater number, and we can see that its coefficient is 1, so we swapped it with this, but it was only partial, because what other thing we could have done was to swap 2 with 0, and we could have gotten even a greater element here, or we could have swapped anything else to get a bigger value at the pivot elements or pivot points. But that is total pivotization. It is not really necessary. If you perform even only among rows, like you find out the greatest element in a row and then exchange it by that, and you don't even need to find out the greatest element in the row. For example, here -2 is pretty small as compared to 2 and 1, but all you need to do is find out if there exists any element greater than this below the pivot element, and then you need to swap it in case the pivot element is smaller than that number. So we can swap -2 with 1 here, and what we have to do is we have to swap the entire row, not just those 2 elements. So anyways, back to our program. So now that I have told you what pivotization is, for I is equal to 0, we will start row wise, and then we will declare another variable k, which will start from the next row, and now there will be a condition if your pivot element, that is I, because for example if I is 0, then you are in the first row, and then when I is 1, you are in the second row, and the second row's pivot element is the diagonal element, which is 1 1 similarly. So if the pivot element is smaller than any elements below it, because k goes from I plus 1, so if you're in I0, then k is in I, so if it's smaller than any elements below it, then we will start a loop for j is equal to 0 to swap the whole row. Now you can go over this code and try to understand what I'm doing, or let me just give you a short review. Like j is equal to 0 while j is less than equal to n j plus is because we need to swap the whole row, so it is for column elements, and then you create a variable temp to store temporarily the value of aij, and then make aij the next element of the element in the next row, and that will be a swapping. Hope you got that. Okay, so now that you have swapped or pivot, you have done the partial pivoting, you can move on to the next part of the Gaussian elimination, that is to perform the Gaussian elimination, which goes here. And this code was to just print the matrix after pivotization. Anyways, now that you are at the Gaussian elimination, what you need to do here is you start reading the elements row wise. I is equal to 0 while I is less than n minus 1 I plus plus. Now so you see here that I'm not going to the last row, I is not going to the last row. Now then you declare another variable that will go row wise, however it will be next 2i, I is 0 and k is 1, and it will go to the last row. Then you declare a variable called t, which will be equal to aki divided by aii, and then for you will declare another, you will start another loop for column elements, and then make the elements of the next row, according to this operation. Now why we perform this is pretty easy to understand. Now in Gaussian elimination, what we need to do is make this -2. For example, take this set of equations and we need to make this matrix, and I told you that 1 and -7 here are the pivot elements, while this whole is the augmented matrix. Now you need to make -2 is equal to 0. So what we do for that is you take -2 and you divide it by 1, which is your pivot element. So similarly what I do here is I take -2, which is the element in the next row, and I divide it by the first pivot element when I is 0. So what I get here is -2 divided by 1 is -2. Then what I do, I subtract -2. I subtract this t times minus t times aij, which would be 1 in this case for j is equal to 0. So t is -2, t times 1 is -2, and so t times 1 is -2, and I subtract this quantity which is coming out to -2 from akj itself, which is -2 right here. So -2 minus 2, -2 minus of -2 will be 0 actually. So thus you will make this element 0, as you can see. So that I'm sure it will sound a little tricky at first, and you might be wondering like, what the hell is it talking about? It's just so confusing. But just go over this for a minute and you would get the idea. Now now you can't just make this element 0 and leave the others, because you have performed a row operation. It needs to be performed over all the elements. For example, here we write add twice row 1 to row 2, and similarly what we are going to do is, that's why it is for j is equal to 0 to j it's less than equal to 1 to n to j plus 1, because this operation is going to happen for the whole row, and in doing so you will ensure that the element below the pivot element will become 0. And similarly, it was only a 2-row matrix. In case you have any matrix with further rows, for example in this matrix which has 3 rows, you would be able to take this idea further and you will get zeros below your pivot elements. And now you print the matrix after Gaussian elimination. This is the code for that, and then you perform your back substitution. Now back substitution was a little tricky for me while I was creating it, and I'm sure, or maybe someone has a pretty easier way to do that than me. So you may like to check that out. Anywho, I managed to come up with a code that would perform the back substitution. Anyways, let's keep back substitution a bit away for now, and let's try this equation that we had here. Okay, so, or maybe this one looks a little better. It's got decimals in it. So let's try to put this equation in our program when we run it. So let me open the terminal here and just, okay, so let me just clear that screen up to avoid confusion. So enter the number of equations. So we have here 3 equations, and okay, so let me just minimize it for a moment, and there's that. Okay, nice. So what are the elements? We need to enter them row wise. 25, 5, 1, 106.8, and okay, 64, 8, 1, 177.2, 144, 12, 1, 279.2. Remember, this is the augmented matrix that we are entering. Okay, so now in our program we can clearly see that 25 is not the smallest value. However, the program would have run if we had then messed up with these its position, but still, to keep as a precautionary measure, we did the swapping, because I told you that 144 was the largest in this column, and that's why we had to swap these rows. Okay, so this was the matrix after pivotization, and then this was the matrix after Gaussian elimination. Now it might not be similar to this one that we have right here, because human calculations can be a bit different, because we have a brain and logic, but computer has to follow some protocols, program for that matter. So, but we are getting the similar value for x3. For example, here x3 is point. Let me just calculate that for you. Calculator. Wait. So 0.2375. That is the RHS divided by 0.2187. That is the coefficient of x3. Would fetch us a value of 1.08, and then here we are getting one. Now keep this in mind that we got 1.08 here, and here we get 0.735, RHS divided by 0.7, and we get 1.05. And I'm a little bit skeptical if that value is correct, because I found my program to be very accurate, so I believe that 1.08 should be the better answer. We can check that out by using back substitution. We can check that out by putting 1.05 and 1.08 there. Anyway, so my computer calculated the value of x3 as 1.08, and then it did some back substitution, like it substituted this value of 1.08 into the previous row, and 0.5556 into 1.0858, and then you got a value. Then it took it to the RHS and got a new value, and then you divided that by 2.667. It was pretty basic math, right? Pretty basic algebra. Anyone who has done a simple course in linear algebra, maybe even a grade 12th grade student, may know that, was senior high school kind of thing. Okay, so that's how you get the answer in back substitution. Now, in case you're wondering that I didn't explain what I did in the back substitution, here's the code, and you can pause the video, download it, whatever, and have a close look at what I'm doing, because to be honest, I made this program long back. I would have to go over it, like what am I doing here. So okay, let me see what am I doing here. Like, I start from the last row. Okay, so we will start reading the matrix from the last row. Then I had declared a matrix, an array called x of size n in the beginning, if you might remember. Don't worry, I will place this code in the description, and you can copy it out from there. So we have an array of size n called x that will store the value of these variables. So xi would be equal to, I is here, the last row. Okay, so the last x, for example in this case x3 would be equal to a3 and the last column. So what I did was I made the value of the third variable x3 equal to 0.2375, but we know that that isn't the correct value. The correct value is 0.2375 divided by 0.2187. So what I do is I start another loop for j is equal to 0, and that would be a full column reading loop. And if j is not equal to I, if the column is not the similar the value, and j is not equal to I, that's pretty basic like that, then subtract aij into xj from xi, because xi was 0.2375, and then you would subtract, in this case aij starts from 0, it is 0, this is 0, and in in both of these cases I was not equal to j, because here j was 0 and 1, but I is 2 actually. So in both these cases it was not equal to I, so it went here. But what it found was that aij was 0, so it never subtracted anything from 0.2375. So xi still remains 0.2375. But then afterwards, finally what we do is we divide xi by aii. So now finally 0.2375 gets divided by 0.2187. Now similarly, if we go in the second row, what this program does is it just gives the value 53.1111 to x2. Then what it does is it starts reading the row. Now it starts reading the row, and here j is not equal to I is 1 and j is 0. So what it does is it subtracts this multiplied by xj from this value, but it is 0, so nothing happens. x2 is still 53.11. Then comes here, but here I and j are equal, so this step would not take place, this step right here. So now it comes here and it sees that yeah, j is not equal to I and we have some value for aij. So what it does is multiplies aij by xj. Now that's tricky. aij, j here is 2, and we have already found out xj, that was 1.0858. Now we have already found out that value, and we multiply 0.556 into 1.0858, and then we subtract that from 53 point this value, and thus we get something looking like 2.6667 is equal to whatever you got here. And then finally what it does is it divides that, and now you finally have x2 here. And similarly then when it goes to the first row, because remember this loop that I started from the last row and it will go to the first row, it was backward loop for back substitution. Now here it will start j from here. Yeah, j is not equal to, j is actually equal to I here, so it will not do anything right here. Then j becomes this, and it sees yeah, j is not equal to I, and we have a value here. So j into xj, j is 1, x and x2 I have already found out, this value. So to multiply this by that, and it will subtract it from this, and then again it will multiply this with the value that I found for 1.0858 and the x3, and subtract that, and finally what you get would be 279.2 or whatever value that you have here divided by 144. And thus that's how you find out your the values for x1, x2 and x3, and that's how you solve linear system of equations using Gauss elimination. And hope this program helps you to understand what am I doing right here. Thanks a lot. I know this video turned out to be quite longer than I expected. Anyways, I hope it's useful for you. Thanks. And don't forget to subscribe if you like it, dislike it if you disliked it, but please don't forget to like or subscribe if you did actually like it. Thanks a lot.